So for today, let's start, before we talk about chemistry, talking about some brownies. So here's a recipe that I try to follow sometimes whenever I use the box mix. And this is the recipe to make 24 brownies, where I add 2 eggs, 3/4 cup of vegetable oil, half cup of water, a cup of chocolate chips, and the entire box of brownie mix. So what I want to know right now, how many brownies can be made if I had 4 eggs and plenty of everything else? Well, this seems pretty simple. If 2 eggs can make 24 brownies, I have 4 eggs. So 4 over 2 means I can make 2 batches, and each batch is 24 brownies, so I can make 48 brownies. Okay. Nothing too difficult here. All we did was just figure out how many batches of brownies I can make with my 4 eggs, knowing that each batch can make 24 brownies. Okay, pretty easy. Let's change up this recipe and make it look like a little different. And let's have a recipe here for ammonia. So in this recipe, for 2 moles of ammonia, we're going to add 1 mole of nitrogen and 3 moles of hydrogen. So let's find out how many moles of ammonia I can make if I have 3 moles of nitrogen and plenty of hydrogen. There's really no difference between this and the brownie example. We know how much of the ingredients we have a recipe, we can figure out how much we can make. So considering that 1 mole of nitrogen makes 2 moles of ammonia, if I have 3 moles of nitrogen, well, that can basically make me 3 batches of ammonia. Knowing that every batch is 2 moles, we can make 6 moles of ammonia. So the context is a little different, but the approach really wasn't all that different if we're talking about a chemical reaction like making ammonia and a simple at-home recipe like making brownies. If we know the starting material, the amount of the ingredients, and the recipe, we can figure out how many things that we're going to make. This is called stoichiometry. What we're going to focus on today is mole to mole conversions for stoichiometry. So what we want to be able to do is calculate the moles of any substance in a chemical reaction. So to start off, we have to know exactly kind of what stoichiometry is. So stoichiometry is nothing but the relation or the calculation of just different quantities in a chemical reaction. So quantities in a chemical reaction are just like the ingredients or the amounts in a recipe. It just indicates the quantity or the ratios of all the different things involved to each other. Much like how 2 eggs have to go in to make me 24 brownies, or 1 cup of chocolate chips has to go in to make me 24 brownies. A chemical reaction is no different, except you just don't usually eat the things that you're making in a reaction. So we compare everything in terms of ratios. So let's take a look at this reaction to make water. We can interpret this as 2 hydrogen molecules combine with 1 oxygen molecule to produce 2 water molecules. So this essentially is my recipe for making water. So if I'm talking about the ratios here, I can take ratios of all the different substances to each other. For example, 2 hydrogen molecules are needed to make 2 water molecules. There's a 2 to 2 ratio of hydrogen to water. 1 oxygen molecule is needed to form 2 water molecules. So there's a 1 to 2 ratio there. And 2 hydrogen molecules have to react with 1 oxygen molecule. So it's a 2 to 1 ratio. These are all the ratios coming from the coefficients of our reactions, 2, 1, and 2. Because this is just like a recipe. The recipe tells you the ingredients and how many of each ingredients do you need to make however many of whatever it is you're trying to make. The coefficients are the quantities, and the ratios, called the mole ratios, are just the ratios of the coefficients of all these different substances to each other. So stoichiometry is just figuring out how many things, the quantities of the substances to each other in relation. So it's kind of looking at an example here where we have a substance A and substance B. So in essence, mole to mole stoichiometry is just converting moles of a substance A into moles of a substance B. We do that by multiplying against a ratio. This ratio, called the mole ratio, is how we relate the two substances together. We get this mole ratio, B over A, based on the coefficients in a chemical reaction. It is just like how if you take a recipe and you're just figuring out the ratio of the different ingredients to whatever it is you're trying to bake. So the important thing here is that the mole ratio could be for any two things in a reaction. Much like how I can take a recipe and interpret it different ways. Let's say I know how many eggs I have. I can figure out, well, how many chocolate chips am I going to need to match that? Or how many cups of chocolate chips do I have? Okay, how many brownies can I make from that? So it's just any two things in a reaction, apply here, that's what the mole ratio is from. So it does not have to be one reactant, one product. It could be two reactants, it could be two products, whatever. Just any two things in a reaction. As long as you have this ratio, you can relate them. So let's take a look at this reaction here. Two irons have to combine with three magnesium oxides to produce one iron 3 oxide and three magnesiums. This is essentially our recipe that we're going to follow. So if I have 1 mole of iron and I want to know how many moles of magnesium oxide do I need to add to match that? It is just like if I had 1 egg and I need to figure out how many cups of chocolate chips do I need to match that for my recipe. So our 1 mole of iron, our substance A, needs to be converted into substance B. We're going moles of A into moles of B. For that, we need to have to know the ratio. The ratio we are pulling from the reaction. The reaction tells me that 2 irons have to combine with 3 magnesium oxides. So my ratio is 3 to 2. I need 3 magnesium oxides for every 2 irons. So 1 mole of iron times a 3 to 2 ratio means I'm going to need 1.5 moles of magnesium oxide. The substance we are always trying to convert to should be on the top of our ratio. This is our want, basically the substance that we want to know about. On the bottom is the substance that we have, okay, that we're starting with. You can see here it's our B over A. So now let's take a look at a different scenario. If 2 moles of iron react with enough magnesium oxide, so that this enough just tells me I don't have to worry about magnesium oxide. I want to know how many moles of iron 3 oxide I can make. Okay, so I've got 2 moles of iron. I got to figure out now how much of this product I'm making. So just like the first example we did, I had 4 eggs. I have to figure out how many brownies I can make from that. So I've got 2 moles of iron. Well, from my reaction, 2 irons produce 1 iron 3 oxide. So 1 iron 3 oxide for every 2 irons. Well, if I've got 2 moles of iron, then I'm going to make 1 mole of iron 3 oxide. 2 irons go in, 1 iron 3 oxide comes out. Okay, and then again, same thing here, but now we have 5 moles of iron. Okay. Just because we have a different starting amount does not change anything. Just like it doesn't matter how many eggs you have at home. The recipe will always be the same. But the amount of brownies you can make will change. So just because I have a different starting amount does not change anything about my recipe here. It's still 1 iron 3 oxide for every 2 irons. So 5 moles times 1/2, well, I can make 2.5 moles of iron 3 oxide. So mole-to-mole conversions is just multiplying against that ratio that's taken from the coefficients of your balanced reaction.